of a quadratic. What are graphs called? Parabolas, right? And there are several parts of the parabola that you learned about. The vertex, you learned about the axis of symmetry, x-intercepts, and y-intercepts. And we basically just looked at graphs of those to pinpoint where those parts were. We're going to start looking at the equations. And from an equation, you could graph it in your calculator.
Michaela Coffee, report to the front office. Michaela Coffee.
You could graph it in your calculator and try to look for those, but it won't always be that they fall on a nice, neat point, so it won't always be visible or easy to find. So we're going to look at some different formulas. So a quadratic, Mr. Taylor told you last week, has to have something in that equation. There's something that tells us it's a quadratic. Does anybody remember what that is? Has to have a squared, an x squared. But there are several different ways that you can write these equations out. We're going to start with the first one, which we call standard form. And this is what it looks like. F of x equals, or possibly y equals, either one. And then you're going to have some number, which we're going to call a for right now. That number is going to be with the x squared. So any number that's paired with x squared, we call a. Plus bx, and you're going to have some number with an x, plus c. So if I ask you for a, you're looking for the number in front of the x squared. You don't say x or x squared, it's just the number. Now some things about a is, if a is positive, that means that your parabola is concave up. Looks like that. So if you have a positive a value, a positive in the front, it's concave up. If a is negative, it's going to be concave down, like a friend. The c value is your y-intercept. And if you write that as a coordinate, it'll be 0, comma, whatever your c is. That's your y-intercept. So just from looking at the equations, there's two things that you can just see right off. The y-intercept and if it's concave up or concave down. What you cannot see right off that we're going to learn to find today is the vertex. It's a very short, brief formula. In order to find the vertex, your equation has to be in standard form. So for example, you have to have the x squared, the x, and the number all on the same side. The x squared is first, then the x, then your plain number. So A, B, C. And the formula you're going to do, x equals, you have a fraction. On top of the fraction, you're always going to have a negative, and then you put your b value. So negative b on top, 2a on bottom. The negative is always there, the 2 is always there.
So if your b is already negative, would that make it positive?
It'll be negative, negative, which will in turn change it to positive, yes. Okay. That is only going to give you the x value of the vertex. To find the y value, you have to plug the x back in. So number one, we're going to start by labeling A, B, and C. What is A?
0.
1. If you don't see a number in front of the x squared, you assume it is a 1. A 0 would be if the x squared was not there at all. What about B? And C? -5. So x equals, this is the x value of my vertex. It's going to be -4 over 2 times 1, which is 4 over 2, which is 2. So the x value of my vertex is 2. To find the y value, I'm going to put that 2 back in for all of those x's. And I believe you get -9. I'm going to show you something you can do in your calculator that you've probably not seen before. This is it's called the store function or the store button. It comes in handy, especially when there are lots of negatives involved. How many of you have ever forgotten to put parentheses around a negative when you squared it? Yes, most of you. Using the store button will allow you to bypass the parentheses and not have to worry about it. Okay, so here's what you do. We want our calculator to know that x is 2. So we're going to type in 2. And then you're going to hit this button that says STO. It's beside of the 1. That means store. And we're going to store it as x. So we're telling our calculator that 2 is x. And then what I'm going to do is type in my equation exactly as it's written. Don't try to think about, well, I can take this negative off. No, type it in exactly as it's written. X squared minus 4x minus 5. And hit enter. And you get -9. It may take you longer to do it this way on some problems, but when you have negatives, it's worth it to do it this way. Especially those of you that have forgotten from time to time. You just get in the habit of always using the store button. So my vertex is 2, -9. What is A? 2. B? C? 16. So to find the x value, it's going to be -b over 2a, which is -12 over 4, which is -3. And then the y value I'm going to replace the x's with -3's. And yes, you can type it in just like this. Might be faster this time. But I'm going to try to get in the habit of using the store button so that I don't make those little mistakes. -3 store x. You have to hit enter and then you type in your equation. 2x squared plus 12x plus 16. And and that gives me -2. So what your calculator is doing is putting the -3 in for those x's. So my vertex is -3, -2. If I wanted to check to see if I was right, I could graph this in my calculator. If you go to your y equals and you type in this equation, when you're typing in y equals, what you have stored for x on the other screen doesn't matter. It doesn't affect this at all. So 2x squared plus 12x plus 16. And then I could look at the graph to see if that vertex looks like it's -3, -2. That looks about right. So let's go to the back where we're going to do a few examples, but now I'm asking for more than just the vertex. But the only thing that we have to calculate is the vertex. My A is what? Good. B, C, 71. So the x value of my vertex is -16/2, which is -8. If you're just going to type this in the normal way, you have to make sure you put that -8 in parentheses. Otherwise, you'll mess up. If you want to avoid that mistake, do -8, store x, and then type in the equation as is. X squared plus 16x plus 71, and you get 7. So my vertex is the point, -8, 7.
Ms. Thompson, how'd you get a -2? Yeah.
I don't know why I put that there. It's -8. Your x is -8. Yep. Which is what I typed in the calculator. Alright, do I have a maximum or a minimum? I have a minimum. Why is it a minimum?
It's a positive A value, so it's concave up.
Yep. So because it's a minimum, because my graph is concave up, like a cup, where is the vertex at?
The bottom.
It's at the bottom. That's why it's called a minimum. And that minimum value, the lowest value, we look at the y value of the vertex, which is 7. So it has a minimum at 7. What is the axis of symmetry? X equals -8.
Yeah, x equals chaos.
What is my y-intercept?
0.71.
Yep. 0.71. Remember on the last page I told you that your C value is your y-intercept. My C value was 71. I want you to work on numbers 4 and 5. There we go. All right. Did you figure out why your vertex, Janae?
Yeah, I put a
Okay, so that was an easy fix. So vertex is at 1, -6, minimum at -6, x equals 1, and 0, -5. Any questions on any of those parts? Okay. Number 5. What is the vertex, Michael?
-7, -10.
-7, -10.
Oh, let's go.
Do you all agree?
Yeah.
Yeah. Good. If you got -7, but you did not get -10, you probably messed up somewhere with the negatives. Max or min, Ethan?
Max at -10.
Yep, maximum at -10. What's the axis of symmetry, Colin?
It is x equals -7.
Perfect. What is the y-intercept, Jay?
0, -59.
Very good.
Let's go lightweight.
All right, last two problems, we're going to actually graph them. When you're graphing, I want you to find the vertex first, and then I'll show you some easy ways to get the other points that are on the graph, because I don't want you to take the vertex and then just freely draw in a parabola. I want it to be more accurate than that. So let's start by doing the vertex. So -12 over 2 times 2, which is 12 over 4, which is 3. And then to find the y value, I plug that 3 back in. Let's do store.
When I look down, I look back up, and you're already done.
So I did 3 store x, and then I typed in the equation to get -2. So my vertex is at 3, -2. And then we're going to create a table. And your vertex is like in the middle. Okay. And we're going to try to find a couple of points above that and a couple of points below that. The long way to find that is to plug in a 2 for x, plug in a 1 for x, and we could do that. But your calculator will give you a table if you want it to. Now you have to make sure that your equation is typed into y equals first. So go to y equals and type in 2x squared minus 12x plus 16. Now, before we move on, I'm going to have you check some settings on your calculator, because it's possible that people play around and they mess these settings up. Okay, so is everybody ready to check settings? Okay. Do you see where above window it says table set?
Yeah.
We want that. We're going to hit second window. Now, right here, table start. You want that to be like -3, -4, -5. If it's something way off, change that.
It's like 0.
0 is fine, but like some people go in and change it to like 200. And what that means is that when you look at the table, you're going to see numbers in the 200s. Okay? So change it to a relatively small number. And then both of these should be on auto.
Wait, how did you get to that?
Second window. You don't have to check this every time, but I figured if we all check the calculators right now, it'll probably be good for the next little bit. And then you're going to actually see the table, you're going to hit second graph because it says table in blue. And you have to hit second graph. So now your table, you can scroll up or down as far as you want, but only some of those points are going to fit on my graph. So you need to go find small numbers. Now, since you found your vertex, you kind of know where to start.
Why's my X taking
You can scroll up or down. So 3, -2, I'm going to go above that and put 2, 0. That's a point. 1, 6. And then 4, 0, 5, 6. If you look at your vertex, we told you that parabolas are symmetric. Going up from the vertex and going down from the vertex, notice your numbers are the same. That's just because that the parabola is symmetric. So like above, I got 0, 6, 16, 30. Below, 0, 6, 16, 30. That's just kind of a feature of the graph. You might have typed in the equation wrong.
What was the equation? 2.
It's on the
Go back to y
paper.
equals 12.
So I did draw some points off of the graph, but these points draw my parabola. So finding the vertex just kind of tells you where the center of your table needs to be. I want you to do that if you're graphing, and then you can just use the table to find the rest. Alright. I want you to try number 7. Alright, if you want to look up here and check, here is what number 7 should look like.
4,